Hey guys, welcome back to the concept of electrolysis. We were dealing with dilute solutions of sulfuric acid electrolysis, and I have written here already that what type of ions will be formed from sulfuric acid dilute solution. It will be H plus 1 and 2H plus 1 from sulfuric acid, and OH1 minus ions from water, whereas SO4 2 minus ions are formed from sulfuric acid. Okay. Now we know this thing that positively charged ions will be attracted towards the negatively charged electrode. And what is the name of the negatively charged electrode? It is called as cathode. It is called cathode. And we can see this thing that this OH1 minus ions are going towards the positively charged electrode, which is called as anode. All right. Okay. At the cathode, there will be reduction, and at the anode, there will be oxidation. Okay. At the cathode, there will be reduction, and at the anode, there will be oxidation. What is reduction? Reduction is gain of electron. I am telling you for the each step again and again so that you people may keep this thing in your mind. At reduction, which is happening at cathode, it is gain of electron, whereas what is oxidation? It is loss of electron. All right. Now we know this thing that SO4 2 minus ions are never getting discharged. In the list of the ions, I have told you that SO4 2 minus ions, PO4 3 minus ions, and NO3 1 minus ions are never going to discharge. Okay. So what will be the equation on this side and what will be the equation on this side? Guys, let me inform you very clearly that this equation of OH is of high importance. Sometimes in the paper of ATP, examiner has asked to write this equation for like 2 marks. Okay, yes, it is so important equation, and I would like to inform you that it is important to write the state symbols as well. Always write down aqueous with every ion because all the ions are in the aqueous state. So what will be the equation for OH? It will be 4OH1 minus arrow 2H2O plus O2 plus 4 electrons. Yes, might be this equation is a little bit challenging for you. Might be this equation is giving you a little bit surprise. Yes, why 4OH has been taken? Why not 1OH has taken? To make the equation balanced, we have to take 4OH. Let me clarify this equation to you. 1OH is going to remove 1 electron. 4OHs are releasing 4 electrons. So we are okay with electrons now. 4OH has how many oxygens? 4. So here, how many oxygens? 2. Here, how many oxygens? 2. Okay. We are okay with oxygen as well. How many hydrogens here? 4. So how many hydrogens here? 4 as well. So we can say this thing that oxygen, hydrogen, and electrons are balanced on both sides. So this is a balanced chemical equation. As we have removed 4 electrons, so we have to gain 4 electrons as well. Now, what will be the equation on that side? It will be 2 electrons. We are going to gain 4 electrons. It will not be 2 electrons, rather we have to gain 4 electrons, and I'm writing like this. Okay, it will be 2 moles of hydrogen. 2 times molecules of hydrogen will be formed. And why it is so? This number which is written before anything in the reactants or in the products will be considered as the number of moles. What are moles? We are going to discuss later, inshallah. But right now, I'm just telling it to you that 4H plus 1 and plus 4 electrons and 2H2. So we can say that number of electrons gained and lost are equal. So what will be the resultant equation that I'm going to write here? Okay, I can select another color. Okay, so what is the resultant equation? It will be 4H plus 4OH1 minus, and the resultant is 2H2O plus O2 plus 2H2. Remember this thing that it is a gas here, it is a gas here, and it is a liquid water, whereas both of the ions will be in the aqueous state. So this is the net ionic equation, the resultant ionic equation, and that's it. Okay. So this is the electrolysis of sulfuric acid. What will be the observation? At the anode, a colorless gas is formed, which is oxygen. And how we can detect this is oxygen, that it will reglow the lighted splinter. So we can say this thing that the gas which is being produced at the anode is oxygen. Okay. One more thing is this: the gas which is formed at the cathode is hydrogen. How we know this thing? What will be our first observation? A colorless gas is produced at the cathode. And one more thing is this: that as it is a colorless gas, we cannot say it is hydrogen. So how we are going to confirm it? That bring the lighted splinter near hydrogen gas, it will pop in the splinter. Okay, it will pop in the flame. So this is the test for hydrogen, and this is the test for oxygen. Examiner is asking about the observation, so you have to say this thing that bubbles of a colorless gas are observed, or might be some of the students are thinking about the word of effervescence. Yes, effervescence is the same word as for bubbling. Okay, so you can say the same thing. Okay, so we are done with the electrolysis of diluted solution of sodium chloride, and we are done with the diluted solution of sulfuric acid. Now we are going to move towards the concentrated solutions now. Okay, guys, if we are talking about the concentrated solutions are those solutions in which the amount of the salt, amount of the compound is higher in the solvent, and that is called water. So what is the term solution? Solution is basically a combination of two types of the substances. One of them is solute and the other is solvent. Might be many of you are aware of this fact already. So solute is the lesser amount one and the solvent is the larger one. So for example, if we are talking about the sodium chloride solution, we can say this thing that in this case, NaCl is the solute and solute, whereas water will act as a solvent. So this is how we can discriminate between the two. So this is the case of concentrated, which are also called as aqueous solutions. Aqueous solutions means water is there, but it is in the lesser amount. Okay, it means that we are going to ionize, we are going to pass the electricity through a compound which is in the aqueous state. What is electrolysis? We have already discussed. I was just going through a paper of 2021 in which examiner has given like 2 to 3 lines and has asked this question: define electrolysis, for like 2 marks. So what is electrolysis? It is a process in which electricity is passed through molten ionic compound or solution of an ionic compound. That solution can be diluted or concentrated. Solution of an ionic compound, and the compound converts itself into its components, converts itself into its ions. This breakup, this process is called as electrolysis. So right now we are going to discuss the concentrated aqueous solutions electrolysis. Okay, let me inform you very clearly about the rule for electrolysis. In this case, basically it is the same, but there are certain changes which I am going to tell it to you. So lower reactivity in case of aqueous I'm talking. Okay, lower reactivity, lower reactivity, positively charged ion, whereas higher reactivity, negatively charged ion will get discharged. Okay, so this is the rule for the electrolysis. Now I am taking you to the NaCl electrolysis, NaCl aqueous solution electrolysis. All right, now what are the ions from this? Na plus 1, Cl 1 minus. And instead of writing here, I would like to write like this. And what are the water ions? It will be H plus 1 and OH 1 minus. If we are looking into the reactivity series of the ions, which are here right now, we can say this thing that Cl is at the higher level, whereas OH is at the lower level. And in case of H and Na, we can see that Na is above, whereas H is lower. Okay, so according to this rule, which I have just written here, low reactivity positively charged ion will get discharged, whereas higher reactivity negatively charged ions are getting discharged. Okay, so where they are going to discharge, they are going towards, they are being attracted. Please, guys, I'm just giving you a reminder again. Both Na plus 1 and H plus 1 ions are attracted towards the negatively charged electrode. Both Cl1 minus ions and OH1 minus ions are attracted towards the positively charged electrode. But out of the one, only one will be able to, out of the two, you may say, out of the two positively charged ions and out of the two negatively charged ions, only one positively charged ion and only one negatively charged ion is going to discharge. Okay, so where this H plus 1 ion is going? Now it is going at the negative electrode. And what is the name of the negative electrode? Again, the same story. It is called cathode. There it will be reduction. And what is reduction? It is gain of electron. Gain of electron. Okay, and now this is moving towards the positively charged electrode. And what is the name of positively charged electrode? It is called anode. And what is happening at the anode? It is oxidation. What is oxidation? It is loss of electron. We can say this thing That equation will be 2Cl1 minus arrow Cl2 plus 2 electrons. Why I am taking 2Cl1 minus? Recall that concept which I have taught you in the chapter of periodic table. All the elements of group number 7, oxygen, nitrogen, and hydrogen, are naturally diatomic. Okay, so here I'm writing 2H plus 1 plus 2 electron. It is going to gain electron, and what will happen? H2 will be formed. Number of electron gained and lost are equal. Now, what is the resultant equation? It will be 2H plus 2Cl1 minus arrow H2 plus Cl2. Okay, this is a gas here, this is a gas here, and ions will be with the aqueous state always. Okay, so this is how we are going to write the net equation, the resultant equation, the sum up equation. Okay, I am now on the other page and we are going to study the lead bromide. This is PbBr2 aqueous solution electrolysis. Okay. And here, what will be the ions here? Electrolysis. Okay. The ions will be Pb plus 2 and Br1 minus. 2Br1 minus according to the formula, and water ions will be H plus 1 and OH1 minus. Again, the same rule, lower reactivity, positively charged ion, whereas higher reactivity, negatively charged ions are getting discharged, where it is going towards the negatively charged electrode. And what about the Br? It is going towards positively charged electrode. We can see this thing, that at the negatively charged electrode, which is called as cathode, at the cathode there will be reduction. And what is reduction? We already know this thing. It is a gain of electron. And what will be the equation? It will be 2H plus 1 plus 2 electrons, arrow H2. We have already 2Br, so we are not going to make it 2. It's already 2 times. Here it is anode. Whenever we are writing any number, guys, I'm letting you know these numbers are to make the electrons balance on equal sides, on both sides. Make the electrons equal on both sides. So this is anode, and at the anode, what is happening? It is oxidation. And what is oxidation? Loss of electrons. So here we are saying it is 2Br1 minus arrow Br2 plus 2 electrons. So number of electrons gained and lost equal. Again, the sum up equation will be at the bottom. It will be 2H plus 1 plus 2Br1 minus arrow H2 plus Br2. This is aqueous now, this is aqueous now, this is a gas, this is a gas. Okay, so this is how we are going to deal with these equations, and this is how we are going to perform the electrolysis of the diluted solutions, aqueous solutions, and molten ionic compounds. We are done with these examples. I'm right now going to take you to the other example, and that is the introduction to active electrodes. Guys, what are active electrodes? Before telling you about active electrodes, let me inform you very clearly that there are basically two types of the electrodes regarding their materials. We have already discussed this thing, that there are one type of the electrodes which are called as inert electrodes. Inert electrodes are those electrodes which are either made up of graphite, which is carbon, or they are made up of platinum as well. So graphite or platinum are the materials which are not participating in a chemical reactions, hence they are considered as inert electrodes. Okay, what about the active electrodes? I have told it to you already that active electrodes are those electrodes which are participating in a chemical reaction, and the products of the electrolysis are based upon these active electrodes. Okay, so right now we can say that inert electrodes are graphite. Don't forget what is graphite. Graphite is one of the allotropic form of carbon, which I have told you while teaching you the topic of bonding, and the other is platinum. I have told you that graphite is a preferred electrode, and why it is so? Because platinum is a very, very expensive metal. So, as compared to platinum, we are going to prefer graphite. And the idea of active electrodes is related to copper, for example. So we can say this thing that in case of copper sulfate electrolysis using copper, or we can say that gold electrolysis using gold electrolysis, gold nitrate electrolysis using gold, or silver nitrate electrolysis using silver, etc., etc. These are all the examples of active electrodes. All right, guys, we are going to discuss about the active electrodes case and inert electrodes case related to copper sulfate solution in detail, inshallah, in the next class. All the best. See you all in the next class.